Okay.
All these variable names are terrible.
_2 _2 at _3 _3 at.
I mean, my brain just says, throw all of this away. Do we have a pair and do we have
three of a kind?
Three of a kind. If we do, figure out which, you know, get the pair. If there's no pair, return 0. Get the three of a kind. If there's no three of a kind, return 0. And then just get the value of the pair and the three of a kind and multiply them by 2 and 3.
Well, that's essentially what you're doing here, right?
Yeah.
So the question is, can we just, no, we can't. So the thing is they have to be different, right?
Yeah, but if you look for, I mean, we can rely on the implementation detail, you know, the details of the game, and say, well, we would have to have exactly one pair and exactly one three of a kind because we only have 5 dice. And so we can say, give us the counts where it's equal to exactly 2. Give us, you know, find the count where it's equal to exactly 2. Find the count where it's equal to exactly 3. And if either of those don't exist, then we don't have a full house.
Can you technically get a full house? Like, is a Yahtzee technically a full house, though?
Oh, that's
right. So if I'd already scored a Yahtzee, I'd gotten 5 of a kind. Like, if I get 5 of a kind again, could I score that as a Yahtzee or as a full house?
The full house. Though I think the way it's looking at, I think the way that it's currently implemented, it would not count a Yahtzee as a full house because it is looking for counts that are exactly equal to 2 and 3.
Right.
I don't know if my Yahtzee foo is not strong enough to know if you can actually do that or not.
Okay, so the thing is that we'd be copying logic. We can't reuse the logic we already have because the 2 of a kind and 3 of a kind are looking for greater than or equal to, right? So we're looking for precision equality.
Right.
But
I would
I'd
say like is equal to where is equal to exactly 2.
Right.
Or first or default, probably. I'm thinking in code here. This is maybe.
Yes. No, go ahead.
If pair is equal to, oh, I guess it won't be null. Default. How about that? So if we don't have a pair, turn 0.
Yeah.
Of a kind. First or default now is equal to 3. And then say, well, if we don't have a 3 of a kind, turn 0.
Otherwise, we have them.
Otherwise, we have them. We have both of them, and we return pair dot value times 2 plus 3 of a kind dot value times 3. Is that what that's doing? Oh, sorry. I guess if I get rid of this, I don't know if you want to comment out all of it or not, but
it's fine.
Well, yeah. The tests think that is right. That works, at least.
Should we go double check the test to see if we
if we believe, how much faith we have in the tests?
I mean, just given that this is a little bit of a trickier case.
Yeah. Oh, hey, look, it does have a 0 case. That's good. So let's see. This one will be 2 times 3 plus 6 times 2. Which is 12 plus 6, 18. Which is 18. Okay. I think I believe that.
The only question is, do we I mean, yes, so it works for the common case of full house. It's just whether or not the Yahtzee case of full house
Oh, yeah,
works, or even scores a full house.
right.
I would think it would, because it's a two of a kind and a three of a kind.
Unless for a full house, the description explicitly says the two of a kind and three of a kind have to be distinct, but
Yeah, well,
I don't know if they do.
the again, it's relying, talking about constraints of the game, right? Like that particular constraint is constraint of poker full houses, right? You can't have five of a kind in a poker full house. So I just wonder. I mean, we can make the rules whatever we want because we're not really doing Yahtzee.
Yeah.
We're doing off-brand Yahtzee.
I'm gonna rename some methods while you're here.
Okay, I'm just gonna do a little Wikipedia search, the rules of Yahtzee.
Okay.
Of like real Yahtzee, that we're not infringing any sort of rights of.
Right.
Full house. Three of one number and two of another. I wonder if it has to be another.
Two pair.
At least according to this, a player will keep a Yahtzee or a full house. Yahtzee will score 25 under the Joker rule. I don't know what the Joker rule is. Oh, this particular Wikipedia article gets into the details of percentages and all of that stuff.
I want to move this one. Really missing the mash down arrows of, mash arrows of writer / resharper right now. Maybe there's a way to do that in Visual Studio. I'll have to have VS Code. I'll have to do some investigation and see. I'm going to put full house there. Well, I just think it should come down here somewhere.
Okay, so apparently, I think technically you're correct. A full house must be three of one kind and two of another, at least according to this description. But apparently there's also a Joker rule in Yahtzee where if you roll a Yahtzee, if you've already rolled a Yahtzee, you can use it to score for a full house, a small straight, or a large straight. But I don't think we're implementing that rule.
Huh. Yeah, interesting. I didn't know that was a rule in Yahtzee. But yes, I think we're not implementing that rule.
So I think, from what I can tell, it does have to be two of one kind and three of another. It cannot be five of the same kind. Which seems a little odd. But it also can be by the Joker rule. So, but I guess that would be implemented somewhere else, right? You'd be like, oh, it's a Yahtzee.
But
so you
we
could
have the Joker
apply
rule
it.
On or off.
Yeah. Since we don't know what other things have been scored, right?
Right.
Because you would have to, I think the rule is you'd have to score a Yahtzee first. So.
Yeah, and currently, though we haven't implemented them, I mean, we have state in our dice, sort of, in our current roll. Like these are essentially, stateless. They don't know about any previous roles or anything like that.
Yeah. Okay. So we've done all of them, right?
Yeah, I think so. Like
Uh,
scrolling through this code, it's not like I want to gouge my eyes out anymore. So
just out of curiosity, how many lines of code were there at the beginning?
oh, that's a good question.
We got under 100.
It was, oh wow, 243.
Okay.
So it's less than half the lines of code.
And we just have that, even that one line that's commented still. So yeah, that's fine.
Yeah.
And so the question is, do we do a dictionary instead? Do we want to do the dictionary and see which of the things would benefit from that? Because I mean, we just do a to dictionary, right? Like it's not.
Oh, yeah, we could do that. Oh, we'll get dumber names, but that's okay. Count dictionary?
Sure.
Counts to dictionary. So give it the 2.
Yeah. I believe that will do it.
Okay.
Okay, so specifically we were looking, well, so,
Oh, go ahead.
well, I'm just thinking like, it'd be good to see if we could at least get rid of one of the 3.
Yeah.
But let's first see, I guess, if count dictionary is actually demonstrably useful anywhere.
Okay.
Because ideally we would consolidate either on counts or count dictionary.
Right. Let's see.
Do we want to try score small straight first and see if that
Yeah.
works better?
That. So if we did, I guess you can type if you want, I guess.
What?
You can type. I typed for the last. You can type for this one if you want.
Okay. So, oops.
Oops. So if we do, and then, so if we go through our enumerable range again and use that as an index in the dictionary.
So in this case, we want to do 1 and 5.
Right.
So we want to do the same thing, like all, and then x dot.
I think we want to do like count dictionary sub x equals 1.
Oh yeah. So basically, exactly like.
Oh yeah. Exactly like with our dice value counts, except it's 1 based instead of 0 based.
Right.
For that one anyway.
So the question becomes, so for that, like, we could just make the array 1 based.
Yeah.
And that would give us the same value.
Yeah.
Right?
I mean, we could do some of the.
Because down here we just do 2.
Yeah. We could do like, I think for like this one. How do you get all of the pairs?
Key value pairs?
Yeah.
Or just, I think you can just
If you
enumerate
just do a
over it.
LINQ, if you just do a LINQ statement on a dictionary.
Yeah, it'll just give you an enumerable of key value pairs.
Okay. So like this would be the
Doing-
same as this, except it'd be,
Key,
sorry.
yeah. It'd be value, yeah.
Times 3. Oh, why does it not like that? Oh, because we, oh, because I didn't dot key on this one. That's not confusing at all.
So that is one of the main benefits I'm seeing of the tuples.
Tuples,
Is
yeah.
that we named them. If it was item 1 and item 2, this would be equivalent.
Right. Yeah, I think there is some value in being able to name the fields of the tuple. Whether it's enough value to have the list of tuples and another data structure, I don't know.
Yeah. Right. So then, so let's just see. Probably, I don't know. My suspicion is this is going to really for reals this time, the last thing we're going to do, as opposed to the LINQ stuff.
Right.
So if we can get it all to a dictionary,
is that worth it?
Yeah. Did we win?
Let's see.
So then down here. Okay, so count is value.
Count is value. Oh, and is that null by default for the key value pair?
Oh, probably. Well, no, it can't be default. Like, yeah, so you're saying
key value pairs nullable? Oh, they are not. They must be structs. You can't do default with those apparent. Okay. I don't know what key value pairs give you, like what the default for that is when you do first or default. Can you do like specify the type here? No, this still does not like that. Oh, because you can't use double equals on it.
Yeah, so we'd have to do dot equals. I think maybe even just using default without specifying the type might work. Need another paren.
Okay. So I think we could do that.
Why is it upset still?
Oh, because
oh, so
this
pair
one,
should be.
that one should be
Key.
Key. Work for just the pair. Yes.
Okay.
Okay.
So if we did the same thing here.
Now it's value.
Oops.
Oops. And that one is key.
Key.
I wonder if the dictionary key and value names would be less confusing if we hadn't started with the
Value and count.
Yeah, with value and count.
Yeah, I don't know.
Because right now it's super confusing for me. But
Okay. Just for kicks and giggles, let's see if we can get all the way to the count dictionary.
okay. I think for score 2 pair, that should be not too hard. Except for remembering which one is which. So this is value.
Value.
Some the key.
Key.
Okay. Oops. This one I think won't be too bad. This one will be value. This one will be key.
That'll be
This
key.
one will be key.
The last are default, might.
Oh. We have one for this that we have a test for that doesn't have a pair, right?
I thought so.
I think we do one pair. Yeah, that one. Okay. And let's do the right thing. Maybe it makes a key value pair with the default value for the two, for the key and the value, which in our case would be 0 for int.
I assume that what it must be doing if it's passing.
Do you want to try to get rid of, replace where we're doing dice also with our count dictionary, or do you just
no.
want to do dice?
Well,
I'm okay if we leave dice for now, because like.
well, let's see. Now I was gonna say no, but now you like put the puzzle down in front of me.
Okay.
Right. So we do count dictionary.
Sub die value, right? Because we just index into it to find out how many of them there are. Times die value.
Wait.
Right?
No, you don't have to multiply it, right? It's just, you're just scoring a single.
Because it's going through all the dice. So in the original one, here, because we took out the zeros.
Well, I think, but like it's failing on. Oh wait, it's the sum.
Because the way it was implemented before, we had dice rolls of 1, 2, 3, 4, and 5, and
Right.
we find all the ones. It would go well. So like if we had 2 ones.
Oh, that's right, because it's the die value, right? You're saying so it's multiplied by the right. Okay, you counts values.
Yeah.
Summing. Okay, so it's still.
We could do a check for the key or something, but.
All right, so
if count dictionary dot contains key, or not contains key.
It contains key.
Yeah, of die value. That's not true, then return 0. Ah.
Okay. Is that better? I mean,
I don't know. The
I feel like it's a little more convoluted.
Yeah, like I like how it's like the original version. Well, the version before this version said, "Hey, just look at all the dice. Find all the ones where it's equal to the value you're looking at. Add them up."
Yeah.
I like that one. Especially the count dictionary sub die value times die value. That feels clever.
Yeah. I'm gonna say this one is a reason to keep the dice around.
Okay. Like for this, in this kind of situation, actually keeping a copy of what all the dice values are doesn't seem like an unreasonable thing to do.
Yeah. Kind of. I mean,
if it were something more complex than just integers, I think, and it was like we were getting into.
well, okay, sorry. Now I'm like, can we? If we did instead, sorry. Now I'm gonna get maybe a little clever.
Okay.
We did dot where x dot key equals die value and dot first or default dot value.
Maybe.
I still think 52 is probably better.
Yeah.
It's at least as clear. But if we were really like,
if we really wanted to have just count dictionary, just
yeah,
a single, I think I like that one better.
Yeah. Okay. We'll come back.
Okay.
Okay. Yatzy should be easy. All right.
Yeah, we should just be able to do, count dictionary. I think we can just do any dot value equals 5.
Yeah. It's basically the same as our 4 of a kind and 3 of a kind.
Yeah.
This is another argument to keep the dice. This is very.
This one we could do with the count dictionary, but it would be a lot more complicated than this.
Yeah.
Because we can go through and multiply each key by the value and sum all those up.
Right? Or no? We could do some.
Yeah, I think we can do some because we'll get an x. So x goes to x dot key times x dot value. Because the value of each die times how many of them there are.
I think that will work.
Yeah.
Yeah.
Okay. I like that we have.
So again, if we really didn't want to keep the individual dice around.
Yeah. Then we could, and that's all of them, right? That was the last one.
I think so.
Okay.
But it does, I think, mean we can get rid of dice value counts.
Right.
And counts. Unfortunately, we have
we temporarily need counts. That. Oh.
Well, no, everything is dependent. They're all dependent on each other.
Okay. We can not have them around. Oops. We can not have them around permanently. We have them around just temporarily. Oh, because yeah, I don't have the names there. So this would be like item 1 and item 2, but I guess that begs the question, could we build this dictionary in a better way that doesn't use all of those? Probably could.
Yeah. I mean, again, the tricky bit with dictionaries, right, is
The whole, do you have this
does
key?
it exist? Yeah.
Yeah, I would probably, especially since we're dealing with a finite set of keys, I would probably just initialize 1 through 6 to 0 and then
Yeah.
iterate through or something like that. I don't know.
Yeah.
Through the dice.
Probably not super interesting
Yeah.
problem. It's one of those things you grind through to get it done, and you test well so that it doesn't break all over the place.
Yeah.
But just for kicks and giggles, can you get rid of dice too? Like we had that one last one. We like
we use it in.
well, we'll use it. We use it below. Well, no, I guess we don't. So it's the next one down.
This one. Oh,
we
right.
swap out 55 and 54. Just
to see if we could do it.
Yeah.
Yeah, apparently we can.
Okay. Just make sure that we're like, I don't remember any, but if there were any like random weird dependencies on that somewhere else. But
right.
So can we delete all the all the commented outlines and then see where we're at?
Yeah. I'm not needing that. I think we have one of those.
We're at 90.
90 lines versus I think it was 243 or something like that.
Yep.
Well, I definitely like this code better. I don't know if I would keep if I would choose to keep the dice because it makes some of these easier, but
yeah. And again, like we said, we would change how the dictionary creation happened.
Yeah.
Since we don't need those intermediate steps anymore, but.
Right. I think we got close. I don't know if it's all the way there. Like the tests and the method implementations are close to in the same order. They're not in exactly the same order, but they're closer. They're way closer than when we started. I might go through and actually make them in the same order.
We also didn't. Yes, I mean, yes. And then we also didn't rename the tests, or did we go through and rename the tests?
I renamed most of them. They're not all like, they might not all be completely consistent yet, but they're closer.
Yeah.
And they're like, the straights are together and the 3 and 4 of a kind and pairs are together, stuff like that. Which I don't think they were. Well, I know those weren't together. I'm not sure if all the 1s through 6s, those were together. I don't remember if those were together or not. That was last time.
Okay, well, I think this little bit of code provided some fun and some rich, different things we got to play with.
Yeah.
Kind of exercise our LINQ skills a little bit and try out some different data types. And I think we somehow ended up with, once I edit this, it'll probably be 3 episodes, maybe 4 if we really want to chop it up smaller. But
hopefully we have some good breaks in there somewhere. But
yeah. Any final thoughts?
No, I think this was a good exercise in some of those common things like it's way easier to refactor when you have tests. Consistent naming and good naming is valuable and helps you. Focus on making the code clear and readable as opposed to clever. Those kind of things.
Yeah, we put some clever things in there, so I don't
There are
know.
a few clever things. But there are fewer clever things than there were when we started with the code, I think.
Yeah, I think it's also good to note that, right, a lot of what we did may or may not be more comprehensible to people based on their familiarity with LINQ.
Yeah.
Which, I mean, is a common thing, right? Like any new language feature, or any new to you language feature, right, might add additional complexity. Any new pattern is going to feel different and feel more complex, but may in fact yield clear, more concise, more readable code once you're familiar with those patterns. So
yeah, there's definitely a point in my career where I would have shied away more from ternary operators. There's probably a point in my career where I didn't like expression bodied methods, whatever they're called. But now there are actually a few more of these that I would probably turn into expressions like these guys.
Yeah.
Maybe that one, I don't know. Multi-line ones, but there are a few of these that I would. But yeah. those are some things that, some other things that if people maybe are not as familiar with, they might be like, I don't really like that, which is totally fine.
And again, it all depends on your level of comfort, your familiarity, amount of time you spent with different language features. But I think it's always good to be experimenting with the new language features to kind of see what situations you do or don't like to use those in, because again, like where we have the method expression bodies, right, in 33, like that I think is a great use of it. When we start to even get into like score chance, like it's like, well, maybe,
yeah,
just kind of, but by experimenting with it a little bit by little bit, then you can kind of see where you like it or where you don't. Again, that's kind of the benefit, like you said earlier, about having tests in place where you can easily go back and forth and try out different things without worrying too much.
Yeah,
I do think at some point for one of these, we're going to have to actually have a Git repository.
Yeah, I did notice that a few times as we were going through. I'm like, oh yeah, we can just change those, and if we don't like it, we can, do a Git checkout. Oh wait, no, we can't do that. Oh, let me think about this more then.
Yeah,
like in a in a real setting, I would be, have some sort of source control and have that as an additional backup, which I think would have helped here a few times. So yeah, I think we should definitely do that.
Yeah. Well, we did have a Git repo here where we could have done it.
Yeah, I at least forgot about it. I was just like, yeah, let's get in the code and go and refactor all the things.